Hello everyone, my name is Lin. In this video, I'm gonna walk through my project from start to finish by doing sentiment analysis on products review. Here's today's agenda. I'm gonna quickly talk about why I'm picking sentiment analysis as my topic, then moving to data overview, also includes data cleaning, explore data analysis, because raw data is not clean and ready prepared for machine learning models. So that's why we have to spend time to clean the data set first. Then we'll move to data visualization. It's a practice of translating information into visual context, such as chart or graph. Lastly, I will do modeling. So it's a use of natural language process to identify the motions behind text. Lastly, I will compare different models, how their performance are. So first, why I'm picking sentiment analysis because it's really widely used nowadays. Many companies are aware of their customers' feeling, what they're doing, how they're saying it, and what they mean. Instead of reading word by word, trying to figure out its sentiment. Nowadays, with the advance of machine learning, humans just let the machine read news or comments for us, and it answers the sentence sentiment or meaning in the faster time. And my project goal is to utilize machine learning to automatically predict whether the given comment is positive or negative. It helps reduce the significant time that the marketing initiatives read every comment and figure out its sentiment. So I think everyone here have experienced shopped at Amazon before, either like online shopping or at Amazon Go in person. But in the real life, it's really widely used. The sentiment analysis can help brand monitoring their customers' perceived about their brand and their products. Also for researchers to gather these analysis to understand the perspective of the population toward particular products. For product improvements, also helpful to understand, identify what consumers satisfy and dissatisfy about. Move to data cleaning and pre-processing. A quick overview about my data set. I linked the data source in the reference page at the last slide. So in my data set, it contains 365 megabits and over 1,500 consumers review. When I look at primary categories, it contains only electronic products like Kindle, Fire TV. So you may see a lot of electronic product words. Next, it contains the basic information we need for this project, like reading, review, reading, text, title. And this dataset collect info from 2010 to 2016. First, in the pre-processing step, I will check all the missing values because missing values could cause errors in classification and modeling. There are different ways to check it, and my way is to replace the missing value with zeros and then drop unnecessary values to avoid any errors later on. Next, well, I converted alt text to lowercase to avoid duplications because sometimes when machine read a word with lowercase and uppercase, they count it twice, which we don't want in sentiment. So convert it out to lowercase. Also during this step, I tokenize each word as well because in one sentence contains many of words, but not all words are important to us. So I will count unique tokens here. Then the next step is to remove all non-text and special characters, or maybe character that's in different language, because it's kind of noise to this data set and for modeling. Moving to the next is remove stop word. Remove stop words in NLTK library package are like objective like I, V, U, not, must, not needed. Those words are likely to represent not like not doesn't have a meaning to it, so the model may consider this as noise. We want to remove it to keep noise level down. Down below here is a screenshot of my outcome. So the original sentences often is not as good as they used to be. Definitely needs to step up their game. And the stop words in this sentence are listed here as not as, they to be, up, there. After remove it, the sentence become often good use, definitely needs step game. But like we can tell it changed the sentence meaning after I remove the stop words here. So we have to be careful with it, the choosing of our stop word. So my way to resolve this issue is I create a list to make sure that when I remove stop word, I don't remove any words I have listed. Moving to the next is lemmatization and stemming. So stemming is a technique which a set of words in sentence are converted into sequence to shorten it looks. So here is the example on the left side. No matter if present or future time or plural or any anything like changer in stemming process, it will change CHANG. But like it's not an English word, so that's why we need lemmatization. It's the process to reduce inflect word to their word stem from the text data, but still having the root word belonging to the language. So if I added the E, CHANGE, make it readable in English. Next, moving to data visualization. So first of all, standardizing the ratings. So the data set is about Amazon products review. Like we all have experience before, we can rate our feedback from 1 to 5. So it's quite important processing phase. So deciding the sentiment of review based on the overall score. If a score is over than 3, like 4 and 5, I will take it as positive. If the value is less than 3, which 1, 2, I will take it as negative review. And if it equal to 3, then I'll take it neutral sentiment. As I can see, for rating who got positives is like 87% are positive reviews, and only like 6% are negative, and 6% are neutral. Going to the next, also look at the average words in different sentiments. So you can see on left side, so the negative reviews have the longer than positive and neutral. The average word is 76.48. And when we look at the word distribution in positive reviews, people tend to reflect less than 50 words. And when we look at negative reviews, or some people wrote like over 550 words to describe how they're not satisfied about their product that they received. And when we look at the neutral, yeah, people tend to write more words to describe like which part they don't like, and then maybe like it's this the product is okay, but like definitely some parts to work on to improve. Next, look at the reviews count over year. From the plot, we can see that the positive reviews are increasing from like 2014 and then reach to the peak around 2016, then start going down, down, down after that. But when we look at negative and neutral reviews, they're kind of like a flatland. They don't have much changes over the years. Also look at review count distribution within a year. So it's quite interesting that the top three, the most review counts are the still starting of the year. My guess is because Thanksgiving and Christmas are like end of the year holiday. We bought a lot of gifts to the others. So we start writing reviews like in January. So that's why January got the most reviews are. The last one I did word cloud. Word cloud is a distribution of the text in a visualization way. Word cloud display the word in different size, indicating the frequency of each word in text. Looking at the word cloud, it shows that the reviews are related to electronic products such as keyboard, and some words are related to customers' experience such as great, love. And because those are all the products are under electronic categories, I think remote, it does make sense here. Like next is model building and sentiment analysis. Finally, in this project, we all know they have like different types of word embedding. In this project, I choose frequency-based embedding, which contains two different vectorizers. They're count vectorizer and TF-IDF vectorizer. TF-IDF stands for term frequency inverse document frequency. We will talk about more details about these two vectorizers in the following slides. And I also used 4 different models. They are logistic regression, k-nearest neighbor, support vector classifier, and random forest. We'll compare these 4 models in different vectorizers and then see their performance. Next, why I'm using Count vectorizer is a great tool provided by scikit-learn library in Python. I used to transform a given text into a vector on the basis of frequency of each word that occurs in the entire text. Down below here is an example. The cup is present on the table, and it will put it in tokens each word, and then can be vectorized as so it's 2 because it's appeared 2 times in this sentence. So that's how it works. So count vectorizer is gives the spread matrix of frequenciness of the word in the document. So that's why it is useful to create models for sentiment analysis. Next is TF-IDF, term frequency inverse document frequency. Down here is the equation of it. So it's a very common algorithm to transform text into meaningful representation of number, which is used to fit machine algorithm for prediction. So basically, TF-IDF increases the value of the words or token which are important for the document. Then moving to vectorizers and classifier. I use count and TF-IDF vectorizer to vectorize the text data in the review column, and then use 4 different classification models for scikit-learn models. After that, I will evaluate the model on this data set, found out the accuracy, confusion matrix, true positive rate, and true negative rate. There are 4 steps I did, or split the dataset into train tests sets, then vectorize the target column, which is review column, and find the accuracy score and true positive, true negative rates. Lastly, we'll run accuracy tests with confusion matrix. More details like the 4 classification I mentioned earlier are logistic regression, k-nearest neighbor, support vector machine, and random forest classifiers. All right, so here is the comparison using logistic regression with two different vectorizer. So on the left side is the outcome from count vectorizer. So we can see the accuracy score got 93, but for TF-IDF, logistic regression got 94, which is like 1% higher than the other one. But when we look at the confusion matrix, so we had to understand what's the each block means. So from left out corner, which is 13, it's the true negative, means when actual negative is correctly classified as negative. Went to the next 46 in this category, it means false positive when actual negative is incorrectly classified as positive. Then moving to the left bottom corner 13, it represents false negative, means when actual positive is incorrectly classified as negative. And the last one had the majority number 771 it means true positive. So when actual positive is correctly classified as positive. We can see like in TF-IDF rather like the T true negative and false negative are zeros, which means this model is really imbalanced. So the true positive and true negative should be like similar number to make sure this model is balanced, and even it's got like higher accuracy score, but the true positive, true negative is really like poor. So let's try a different model, see if have a better performance. Now it's KNN in count vectorizer and TF-IDF. So let's see, they got the same accuracy score, which is 93%. When we look at the confusion matrix, they still have the same issue. It's really imbalanced, especially for count vectorizer, they got 0 in true negative. So we had to check out different ones, see if they have like better performance. And support vector machine in two vectorizer, you can see, oh, the accuracy score are the same, but when we look at confusion matrix, oh, they got 0 true negative and false negative, like there's no negative feedbacks at all, which we know is not real in the real life. So this model may not suitable for this dataset at all. Moving to the next, the last model I tested is random forest. Compare different amount to vectorizer, we can see that the accuracy score for convectorizer it got 94%. For TF-IDF, it got the lowest, 87%. When we look at the confusion matrix, both of them are not ideally perfect, but like TF-IDF slightly better because they do have a really little number in true negative, but like when we look at the false positive and false negative, like the numbers are high, that's make it the accuracy number low. Here is the outcomes among all the models that I tested. Logistic regression in count vectorizer is the best, I would say. Because not because overall the accuracy, but also they do have like some models in true positive and true negative. Support vector classifier doesn't seem to be like suitable for this project at all. through true positive and it looks good, but true negative looks very poor. It's like binary. Absolutely numbers. It shouldn't be like that. So from the outcome, I got a little shocked because convex rather gives number of frequency, which represents to index of vocabulary, whereas TF-IDF consider overall documents of weights of words. But from my analysis, they have like very little difference of performance. So it may be something to do with my data set. I may have to try a different set of data, see their performance, but I think it's for the future project and research. Here's my reference, and thank you so much for listening.